So my children, the next application which is very important, here we are going to study a car or a body or a bus or whatever it may be. Here I say that it is traveling with some speed, okay, or I say that it covers some 100 centimeters, nothing but 1 meter in some given time, let it be 2 seconds. And later on I say that because of that road, okay, uneven road, roughness of the road, it cannot move with the same velocity. So it travels with different velocity or less velocity. Okay. So now it covers some less distance, nothing but 128 centimeters, something around like that, in 4 seconds. If two different cases are given and I ask you, okay, what will be the velocity at the end of 8 seconds? So what must be the answer? How we do that? Repeating, my dear children, a body moves 100 centimeters in first 2 seconds and 128 centimeters in next 4 seconds. This is what is the given data. Now my interest upon is that we have to find out its velocity at the end of 8 seconds, provided if it moves with a constant acceleration, means uniform acceleration. If that is the case, then how could we solve it? Okay, so let me write down this. A body or a car moves 100 centimeters in first 2 seconds and 128 centimeters in next 4 seconds. This is what is given data. So it covers 100 centimeters in first 2 seconds and 128 centimeters in next 4 seconds. Moves with a uniform acceleration. Okay, we can say moving with a uniform acceleration. Now we have to find velocity at the end of 8 seconds. This is what is the given question. Find out the velocity at the end of 8 seconds. Okay, my dear children. If this is the data, how could we solve it? Really telling you, here I will include 2 to 3 different applications, nothing but 2 to 3 different formulas I will be using, and I will relate each and everything. Okay, very good, a very important application, very important concept, right? So now, let me draw the diagram for this one. So here a body has been started. Let me name this point as A. So from here to here it has been moving, right? So what is saying? A body moves 100 centimeters in first 2 seconds. So this point, let me name it as B, and the distance from A to B as given in the question, it is 100 centimeters. So here to here it is 100 centimeters. Let me write distance, that is S, from A to B is equal to 100 centimeters. This happens in first 2 seconds. So time taken from A to B, or let it be T1, that's your wish, which is equal to 2 seconds. Next, what was given? It covers 128 centimeters in next 4 seconds. So from B to point C, clear? So here, let me assume what, let me take it as 128 centimeters. Okay, in a span of 4 seconds. So time taken from B to C, or you could write T2, you can write it as 4 seconds. Is it clear? So this is equal to distance covered from point B to C, which is moving with an uniform acceleration. Moving with an uniform acceleration. So this is the way I'll write acceleration. Now my interest is that we have to find out the velocity at the end of 8 seconds. We have to find out the velocity at the end of 8 seconds. Okay, how? So let me take individual cases here. So at point A, and here I never mentioned that it is starting at rest. So no rest. No rest in the sense the initial velocity is not at all equal to 0. if it says the body starts from rest, then we have to say that initial velocity is equal to 0. But here nothing like that, there is no rest. So what will do? What I will do? I just take the initial velocity at this point A as u, simply u, okay? So here nothing is given, so let me assume that initial velocity at point A is equal to u, because nothing was given here. We are not mentioning that the body is starting from rest. So directly can say that its initial velocity at point A is u only. U only. Now, observe my dear children, from point A to B, what was the given data? So based upon this given data, what relation we have to use? We have studied 4 different equations of motion. Yes or no? Now in that, which one you have to select? That is one important task. It just depends upon the given data. My dear children, here time is given, distance is given. So I told you that S is equal to ut plus half at square. In that formula, time t is there, s is the distance that was given here. So why don't you take it? Because already you assumed that velocity is u at point A initially. So better to use that now, right? But I cannot go for equation 1 and equation 2. Why? Because in equation 1 and equation 2, 2 velocities and time, or to equation 3, it is 2 velocities and distance. Here the other velocity I don't know. Okay. If you want, still we can go, no problem. But here not required, that's it. So from equation 2, you could write it as S is equal to ut plus half A into t square. So suffix. The most important part here is that suffix. Okay. So coming to the suffix, so A here is initial point. So initial is this one, A, and B is final point. Okay. So the total distance from A to B. So why don't I write here A to B is the distance, and time taken is also from A to B, and this time taken is also from A to B. Nothing to write about acceleration, because the whole journey is covering under uniform acceleration. The whole journey is under uniform acceleration. Then why should I write again something A to B, B to C like that? Not required now, because from point A to B and then to C, it is under, the acceleration is under A. So nothing to write there. Now from point A to B, it was given this data as 100 centimeter. Remember my dear children, it is centimeter. Okay. So velocity, you are assuming this one as u, and time from A to B is given as 2 seconds plus half A into 2 square. So this and this has been cancelled. 100 centimeter is equal to 2u plus 2a. So why don't I take this 2 as common and write it as u plus a? So now this 2 and 100 I could cancel it and I could write 50. So finally u plus a is equal to 50. So this is what is equation number 1. So this is what is equation number 1. Okay my dear children, right? Now I can take from point B to C or from A to C. No problem. Whatever I like, I'll take it. Okay, no problem. But which one is better, B to C or A to C? I prefer A to C only. Why? Because at point A the velocity is taken as u. You know it. But at point B we don't know. If you write B to C, here you have to put u suffix B. It means you have to know B. Okay, we can find out, no doubt in that. But why should I do that? If I do that, the complex level in the problem will increase. So I don't want to go for that. Already whatever the data it was given, directly I use it. Why should I go for some other data? Okay. Now, so now point from A to C, let me take. A to C, same formula. S is equal to ut plus half into A into t square. Now, this point A is known as initial and C is known as final. So, since it is initial, I could write A, and A to C is the journey. So, distance from A to C and time also from A to C. Like this I could write. Okay. Now, what is the distance from A to C? Just look at the figure. From A to B it is 100 and B to C it is 128. So, therefore, distance from A to C is nothing but distance from A to B as well as distance from B to C. So this is 100 and this is 128, which is equal to 228 centimeters. 228 centimeters. So here this point is 228 centimeter. At point A it is u, and from point A to C, observe carefully. From point A to C is A to B plus B to C. So A to B it was given 2 seconds and B to C it was given 4 seconds. Clear? So total it is 6 seconds. This is the time from A to C. Now 6 plus half, A is constant as it mentioned, okay, and time from A to C is 6 whole square as per the t square is there, no? So I have to put 6 whole square. Here also time taken from A to B whole square, so 2 whole square. Now this 228 is equal to 6u plus 36 by 2, that is 18a. So what I can do? I can leave like this, no problem. Or I could further simplify it to make it easy. So all these three are multiples of 6. So why don't I reduce this complexity? So here what I do is that simply by 6 I can divide. Now 6 3s are 18 and 48. 6 8s are 48. Like this. Okay. So what I am getting finally here is that 38 is equal to u plus 3a. So this is equation number 2. So right now I am having two equations, u plus a equal to 50 and u plus 3a equal to 38. Okay. So here u and a, two unknowns. Here also u and a, two unknowns. If there are two unknowns, we have studied in our school that if there are two unknowns, we need two equations. So this is equation 1 and this is equation 2. So if two equations are there, you can find out the two unknowns. Okay. How? How to find out those? Let me write. U plus a equal to 50 and here it is u plus 3a equal to 38. So this is equation 1, this is equation 2. Just what I have to do? Subtraction. So here I have to write 1 minus 2 equations. So u and u cancel, a minus 3a. So you will get minus 2a, 50 minus 38. Okay. 50 minus 38 is 12. From this, 2 minus 2a equal to 12. So a equal to minus 12 by 2. So that is a equal to minus 6. Since the given values are in centimeters, I have to put centimeters per second square. It's not meter per second square. It is centimeter per second square. Understood now? Since we have two equations, by solving those two equations, we can find out two unknowns. One is acceleration, isn't it? Other one is velocity. So now you know this acceleration. Why don't you find this initial velocity? By substituting the value of acceleration, my dear. So let us take this. So from equation 1, 50 equal to u plus a. Here a is nothing but minus 6. So when minus 6 comes this side, 56 is equal to u. That is, you have to mention units also. Since everything is in centimeter, so velocity unit is centimeter per second. Okay, my dear children. So observe carefully, two unknowns. So already we know acceleration. By substituting that, you will get initial velocity. But our interest is that we have to find out the velocity at the end of 8 seconds. So still it is not completed. Still we have to do something more. Okay, here I give you 2 minutes of time so that you can just observe each and every point carefully and then we can go for the next one. So the remaining part we have to do it now. So what we have to do? We have to find out the velocity at the end of 8 seconds. Where? You are having acceleration value or having initial velocity. Then how to find out the velocity at the end of some seconds, 8 seconds or 10 seconds or what it may be. How to find out those things? As I told you earlier, there is one formula between velocity and time. V equal to u plus at. Earlier I have mentioned that the formula to find out the velocity at the end of t seconds. Repeating. Velocity at the end of t seconds. Some time is given. So v is equal to u plus at. Okay. So here in place of t seconds, there is 8 seconds. So just instead of t, you put 8. Enough. Everything is over. Okay, my dear? See the way I do here. We know that what? Velocity at the end of t seconds, v is equal to u plus at. Velocity at the end of t seconds. Okay. So now let us substitute everything. You got this value of u, initial velocity is 56, whereas acceleration is -6. Okay. And the given time here it is 8 seconds. So in place of t, this is what we have to know. 8 seconds. 8. Okay. So now it is 56 minus 48. That is 8 centimeters per second. So this is the value of velocity at the end of 8 seconds. Understood, my dear? Okay. You can have some doubt why this acceleration is a negative. If the acceleration is negative, it is nothing but negative acceleration. So you should not call acceleration. Negative acceleration. The other name for negative acceleration is what? Deceleration or retardation. Deceleration or retardation. Understood? Is it clear? So before I am moving in a vehicle, okay? So before I want to stop the vehicle by the application of the brakes, it will reduces its speed slowly, so the speed will be reduced and finally it will be 0. At that moment, we are not giving acceleration, we are giving negative acceleration. That is, what is that? Retardation. That is retardation, also called as deceleration or negative acceleration. So if you get the answer in terms of negative acceleration, it means that the body or the vehicle or whatever it may be, it is slowly coming to rest. Okay. Now, you can note this very important concept, my dear. In this one question, what we have done, 3 different cases we have studied. So application that S is equal to ut plus at square from A to B as well as from B to C, 2 different things we have observed, and from 2 different equations we have found out the 2 unknown parameters, that is u, initial velocity u as well as acceleration. By knowing this particular data, my dear children, after the given question, we have found out the velocity at the end of 8 seconds. So this is third application, right? In like this, 3 different formulas we are using here. It means we are learning 3 different concepts. Yeah. So please note down this. Okay, children. Now we'll go for the next concept or next application. I say that there is a car, okay, which is initially at rest and moves with some uniform acceleration A. Telling you, my dear, a car is initially at rest and moves with an uniform acceleration A. Okay, and after some time we observe that bike is overtaking the car. Okay, it means the bike is crossing the car. You can say crossing or overtaking. At that instant, at that point of time, the initial velocity of the bike is u. Is it clear? Now, our question is that when and where they meet each other. When and where they will meet each other. And what is the velocity of the car with respect to the bike? This is what we are going to discuss. And what is the velocity of car 9? Velocity of the car with respect to the bike. Understood, na? So let me write down the question. A car starts from rest and moves with uniform acceleration. That is A. Okay. A car starts from rest and moves with uniform acceleration A. Now, a bike overtakes a car, or you can say a bike crosses a car at some point of time which is moving with initial velocity. So initial velocity of the bike is given, which is moving with initial velocity u. Okay. So we are saying that the bike is crossing a car. So my question is that when and where they meet each other. When and where they meet each other. Next one is that find the velocity of the car with respect to bike. This is what the question. Okay, my dear children. So what I am saying is that initially the car is at rest, which is moving with an uniform acceleration. A were given in the question. Now we observe that a bike is overtaking. It means that it is meeting them. Okay, meeting the car. Okay. Now the bike is crossing the car. Initial velocity of the bike is u. Initial velocity of the bike is u. So when it crosses, what I have to say is that at what point of time they are crossing each other or they are meeting each other. When and where they meet each other. Now find out the velocity, means you have to find out the difference of both the velocities, that is velocity of the car and bike. But my interest is that I don't want separately the car velocity and bike velocity. Velocity of the car with respect to bike, whether it is more than the bike or less than the bike. If it is more, how much? If it is less, how much? Okay, so the answer will tell you. If it is more, the answer will be in positive value. If the answer is negative, then the velocity of the car is less than the bike. That's it. So let us discuss this in detail. So you have to draw a car. So let me say this is a car. Starts from rest. So when it is at rest, its initial velocity u equal to 0. This is what the data given. The car is starting from rest. So coming to the car data, what I have to say that starts from rest. So initial velocity u equal to 0 and moves with an uniform acceleration. So initial velocity of the car is 0, acceleration of the car is a. Okay. So on the other side there is a bike. Like this. So here, coming to the bike, it was given that initial velocity of the bike is u. So initial velocity of the bike is u. Okay. Now a bike crosses a car at some point of time moving with initial velocity u. It did not mention its acceleration, but we have to say that it is moving with an initial velocity u or constant uniform. Let me say a bike is moving with an uniform initial velocity and as well as uniform velocity. Let me say uniform velocity. So uniform velocity in the sense the final velocity of the bike is equal to initial velocity of the bike, which is equal to u. Coming to acceleration of the bike, the formula is change in velocity by time. Change in velocity means final minus initial by time. So final velocity of the bike and initial velocity of the bike both are equal to u. Okay. So u minus u by time t, which is equal to 0. So acceleration of the bike from the given data is equal to 0. Understand? Since it is moving with uniform velocity, we can directly say that this acceleration a of a bike is equal to 0. That is what we can say. Now, how to calculate when and where they meet each other? How to calculate? We are saying that they both are meeting. They both are meeting. Now, what does it mean? Here, now a bike crosses a car at some point of time. So here I have to mention one more point, that both of them are starting at the same instant. Both of them are starting at same instant. Crosses a car at some point of time. So if they both are starting at same instant, so what I could write here is that if both car and bike starts at same instant and they crosses each other after some time. It was very clear that then the distance traveled by the bike will be equal to distance traveled by the car from this data. So what is the formula for distance? This is the same thing. Distance traveled for t seconds, it is equal to S is equal to ut plus half at square. Ut plus half at square of bike is equal to ut plus half at square of car. Okay. Right. Now, I mentioned you that initial velocity of the car is 0. So here this u of the car is 0. And here I mentioned that acceleration of the bike is 0. So this acceleration of the bike is 0. 0 and anything is 0. So what was there here is that u into t is equal to half a t square. This u into t belongs to bike, B for bike, and acceleration belongs to car, C for car. Acceleration of the bike, okay, acceleration of the car as well as initial velocity of the bike. So look at the data. Acceleration of the car is a. So this half a into t square because the acceleration of the car is a. Whereas initial velocity of the bike is u. So same thing I will write u into t. So now this t has been cancelled. So what you get here is that u is equal to at by 2. From this t is equal to, this 2 comes this side, 2u by a. This is what is time t. What is this time t? You are asking now. When and where they meet each other. So when itself tells you the time. So this is the time at which both car and bike will meet each other. When in the sense you have to find out the time, right? So here this time t tells you that time at which both car and bike meets each other. Understood, my dear children? Repeating once again, initially car is given, you are saying that it is starting from rest, so its initial velocity is equal to 0. You are saying that it moves with an uniform acceleration, so uniform acceleration of the car is a, given in the question. Now coming to bike, so we are saying that a bike is moving under uniform velocity, so acceleration is equal to 0. So bike initial velocity of the bike is u, okay. Uniform velocity means the velocity is not at all changing, it is changing at any point of time. So final velocity of the bike is equal to initial velocity of the bike, which you have taken it as u, whereas acceleration, how I am saying it is equal to 0, the acceleration formula is given as change in velocity by time, del v by t, nothing but change in velocity by time. Here it is moving with same velocity. If I ask you what is the change, nothing, there is no change in that, so the change in velocity is 0. So 0 by t, nothing but equal to 0. Understood, na? So this is the acceleration of the bike. Now here we have one silent point is that both are starting at the same point, at the same instant of time, and we are saying that both of them are crossing each other after some point of time. Crossing in the sense the distance covered by the car is equal to distance covered by the bike. So distance covered by the car equal to distance covered by the bike. So we know from the equation 2 that if you want to find out the distance for t seconds, s is equal to ut plus half a t square. S is equal to ut plus half a t square. So that is what I have written here. As for the given data, acceleration of the bike is 0, so this has been cancelled, and initial velocity of the car is 0, so this u value of the car is equal to 0, it has been cancelled, and from the remaining data I found out that the time t equal to 2u by a. What is the time? The time at which both car and bike meets each other. Okay, time at which both car and bike meets each other. Still the question is not completed. Something is there. What is asking? Where they meet each other. Where in the sense we have to find out the distance at which they meet each other. So find out the distance. Already the formula is there now. distance bike and distance car, both are equal. You can take any formula. You get the same answer. You can find through this distance covered by bike is equal to so and so, or you can also take this distance covered by car is equal to so and so. If you can take any formula, okay, or you take both the cases. What is happening? We have already mentioned that distance covered by the car and bike both are equal. So you'll get the same answer. Let us try. Distance covered by bike is equal to ut plus half a into t square. So this is related to bike. Okay. So in bike, initial velocity is u and acceleration is 0. So this part has been cancelled. So only u into t is left, where t is equal to 2u by a. So answer is 2 times of u square by a. So distance covered by the bike is 2u square by a. Okay, my dear children. Now, on the other side, you can take this also. You will get the same answer. Just to improve your level of confidence, I am doing that for you. I am just doing because for you only. So, distance covered by the car. Okay. What is its formula? ut plus half into ad square of the car. Already mentioned that the initial velocity of the car is 0. So, this part is 0. Half a into t square. So, what is t there? T is nothing but 2u by a into whole square. So, what you are getting here is that half into a into 4u square by a square. So, here you have to divide. A and a cancel. 2 2s are 4 and this has been cancelled. So, 2u square by a. The answer is 2u square by a. So, this is what is the distance covered by the car. Now, observe children, in both the cases, you just observe in both the cases, what was the answer? 2u square by a, and here also it is 2u square by a. So, in both the cases, you got the same answer. That's what I am telling. That is the magical. You can use any formula. But because previously we mentioned both the distances are equal, now also you get the equal value. Isn't it? So, the distance or the question for where they meet each other is nothing but at 2u square by a, both bike and car will meet each other or will cross each other. Understood now? At this point of distance, both of them, both in the sense car and bike are meeting each other, are crossing each other. Still the question is incomplete. We did not solve it completely. Okay, the last point is that we have to find out the velocity of the car with respect to the bike. So, how to find out this? Velocity of the car with respect to bike. How to find out this? How to find? So, now, formula to find out the velocity after t seconds. V is equal to u plus at. This is what is equation 1. If you observe every time I am using all the 3-4 equations, mainly 1, 2, 3. These are the 3 equations I am using in every case. Okay. So, because he is asking velocity, final velocity means what? After some time. So, velocity after t seconds. What is the formula? V equal to u plus at. So, for a car, velocity after t seconds, V is equal to u plus at. Okay. Here, initial velocity car is 0. So, this formula belongs to car. Initial velocity is 0. And time that you got here is 2u by a. So, time t is 2u by a. So, a and a cancel. So, now the velocity of the car after t seconds is 2u. Velocity of the car after t seconds is 2u. Then, what is the velocity of the bike again after same time, after t seconds? That's what is the question. Coming to bike. Again, V is equal to u plus at. It was clearly given that initial velocity of the bike is u and acceleration of the bike is 0. So, u plus 0 into t. So, velocity of the bike is u. Okay. Now, we have to find out the velocity of the car with respect to bike. Velocity of the car with respect to bike. Velocity of the car minus velocity of the bike. velocity of the car y minus velocity of the bike. So that is equal to velocity of the car is 2u, velocity of the bike is u. So the answer for this question is u. Okay. So VCB, nothing but velocity of car with respect to bike. So what you got here? Velocity of car minus bike is equal to u. So let me write here. So this is nothing but velocity of car with respect to bike. Okay, my dear children? I hope it is very clear. Okay. So take some time, observe it repeatedly. Definitely you will understand. Very important concept, right? So children, now let us look at the next question, okay? Next concept. Here we are saying that there is an alpha particle. I hope you know what is alpha particle. Nothing but helium. Helium, okay? He24. Helium. Its atomic number is 2 and mass number is 4. So there is an alpha particle traveling inside a tube of length 2 meters. Of length 2 meters. Of a particle. Accelerated under uniform acceleration. This is very important. So now this is under uniform acceleration. So whenever I say uniform acceleration, what you have to remember, you know, these 4 equations of motion, isn't it? V is equal to u plus at, that is first equation. S is equal to ut plus half at square, second equation. V square minus u square is equal to 2as, third equation. And Sn is equal to u plus a by 2 into 2n minus, that is fourth equation. Out of these 4, the first 3 are very, very important that we have to use in every concept. Okay. Now, so it is moving under uniform acceleration. Now, how long is the particle in the tube? What do you mean by how long? Means time. But for how much time it is staying inside the tube? If this is what is the acceleration. If it enters at a speed of 100 meters per second and leaves at 9000 meters per second, so what is its acceleration during this interval? So, 2 things we have to find out. First thing is that we have to find out how long, means time. We have to find out the time. And second thing is that we have to find acceleration. So in this particular question, we have to find out the time until or time up to which the alpha particle is inside the tube. That is first thing. Second thing is that acceleration. What is the acceleration of during this time interval? Okay. So let us see. So we are taking a hollow tube, right? So let us say that this is a hollow tube. So of length, how much? 2 meters. Length is 2 meters. Now it is under uniform acceleration. So it is under uniform acceleration. So it was given in the question that the alpha particle enters at a speed of 1000 meters per second. Let this be point A and let this be point B. So while entering, velocity at A, it is equal to 1000 meters per second, and while coming out, velocity at point B is 9000 meters per second. So there are 2 things given here. So now what we have to do? We have to find out the time, how long is the particle in the tube. So for how much amount of time it is inside the tube, what? Alpha particle which is traveling with this much of speed, okay. So it's for how much time it stays inside the hollow tube. That is what we have to find out. And second thing is that what is the acceleration of the alpha particle? That is second concept, right? So how to do that? My dear children, again and again I am repeating. Previously I told you that if 2 different velocities and length or distance, you can say length of the tube is 2 meters or the distance traveled by alpha particle, both are same only, na? So alpha particle is traveling inside a tube. It means the distance covered by the alpha particle is equal to length of a hollow tube, isn't it? So both length and distance, both are same here. So the distance from A to B is 2 meters. Or length of the tube is also equal to 2 meters. Is it clear? So when 2 velocities are given and distance is given, as I said earlier, we have to go for equation 3. What is that? V square minus u square is equal to 2as. Is it clear? So V square minus u square is equal to 2s. Our journey is from point A to B. Point A to B. So A, stands for initial and B stands for final. So this is initial, so that is point A, and this is final, that is point B, and the distance is from A to B. Is it clear? Now let us solve this. So it was clearly mentioned that velocity at point A is 1000 and velocity at point B is 9000. So one more thing children, don't get confused. Here I am writing UA and here it was given VA. So don't confuse. Okay, what you feel is that U stands for initial and V stands for final. Okay, that's okay, but still at point A the velocity, you give stress at point. What point is at velocity? So velocity at point A is 1000. Whether it is initial or final, that is secondary. Don't worry about that. At point A the velocity is 1000. That's it. Like that you keep your mind. Okay, you set your mind like that. So at point A the velocity is 1000, which is equal to 2 times of acceleration. Distance from A to B is 2 meters. Like this we'll get. Okay. So here what I am going to get here is that 9 in, let me write this as 9 into 10 power 3, because 3 zeros, no, 10 power 3, and this is 1 into 10 power 3. So whole square, 9 square is 81 into 10 power 6, and this is 1 square into 10 power 6. Like this I will get. So here this is 4a. So now 81 and 1 and 10 power 6 is common. So 10 power 6 is common in both the cases. 81 minus 1 is equal to 4a. So 10 power 6 into 81 minus 1 is 80, which is equal to 4a. So 420 is 80. So what I am getting here, 20 into 10 power 6 is acceleration, or I can write it as 2 into, since 1 0 is there, you could write it as 10 power 7. Okay. Since the units are in meters, meters per second square. Understood? Any doubts? So the acceleration in this case is 2 into 10 to the power of 7 meters per second square. Now the other one is the time. For how much amount of time the alpha particle is inside the tube. So how to find time if two velocities are known? You better go for equation number 1. That is V is equal to U plus AT. So next, equation number 1, V is equal to U plus A into T. Okay, my dear? So journey starts from A to B. So A is initial and B is final, and time taken from A to B. It was given that VB is equal to 9000 and velocity at point A equal to 1000, and acceleration just now we have solved, it is 2 into 10 power 7, 2 into 10 power 7 into time taken from A to B. This is called 1000 coming this side. So that is 9000 minus of 1000 is equal to 2 into 10 to the power of 7 into time taken from A to B. So that is 8000 is equal to 2 into 10 to the power of 7 into time taken from A to B. So 8 into 10 to the power of 3, because since 3 zeros are there, I could write 10 power 3. Okay, which is equal to 2 into 10 to the power of 7 time from A to B. Now you better simplify this. So here 2 4s are 8. If this 7 comes this side, it is minus 7. That is 4 into 10 to the power of 3 into 10 to the power of minus 7 is equal to time from A to B. So you know the formula. A power x into A power y is A power x plus y. Here A is 10, x is 3. A power y means 10 power minus 7. The answer is A power x plus y. That is 3 minus 7. So 4 into 10 to the power of minus 4 is the time from A to B. So this is the question. How long is the particle in the tube? So if you want to find out the time, okay, taken for the alpha particle to move inside the tube is 4 into 10 to the power of minus 4. Understand? So here if you want, you could write one more thing. 4 into 10 power minus 1 into 10 power minus 3. So what is this 4 into 10 power minus 1? 4 into 10 power minus 1 is nothing but 0.4 into 10 power minus 3. What is this 10 power minus 3? 10 power minus 3 is known as milli. 10 power minus 6 is known as micro. Okay. So here, this you can write it as 0.4 millis, time it is seconds. So time taken from A to B for the alpha particle to remain inside the tube is 0.4 m. M small m stands for milliseconds. Okay. Or else you could write in other way. Multiply and divide by 100, what will you get? The multiply and divide by 100 into 10 to the power of minus 4. This is TAB. So here this 10 power 2 zeros are there. So 400 into 10 power minus 2 into minus 4. So you will get it as 400 into 10 power minus 6. What is this minus 6 minus? Just now I told you 10 power minus 3 is millisecond and 10 power minus 6 is microsecond. So 400 microseconds is the time taken for the alpha particle to come out of the hollow tube. Okay, so both the answers are correct. So here I am telling you 10 power minus 3 stands for milli, 10 power minus 6 stands for micro, 10 power minus 9 stands for nano. Is it clear? So if you know two different velocities and if you want time, the only relation is that v is equal to u plus ab as per equations of motion. This is equation number 1. So we know these two velocities at point A and point B have substituted and the value of acceleration from the previous data, and now we are going to find out the time. So by simple simplification, by further simplification of all these things, we will get the time taken from A to B. A to B is nothing but the time taken by the alpha particle to remain inside the tube. Okay, inside a hollow tube. I hope it is very clear, right? So you take some time to observe it, you will understand better, no doubt in that.